Okay, so given a six-sided number cube, what is the probability of rolling a 5 and then a 3? So I notice that this is an and problem, and I got to ask myself, do these two things depend on each other? The probability that I roll a 5 the first time and then I roll a 3 the second time, these two things are independent. When I roll a die, there's nothing I can do to that die to make you not get a 3 on the second roll. I can't put the dice in my pocket. I can't take the number 5 off of it. These two things are completely independent. I can't manipulate the second probability so that your chances are smaller. I can't. So the probability of getting a 5 and a 3, what the question asks for, is going to be equal to the probability of 5 times the probability that I get a 3. And I don't really need to think much about the probabilities because I said that these are independent events. So the probability that I get a 5 is 1/6, and the probability that I get a 3 is also 1/6. I multiply the tops together and the bottoms together, and I get 1/36. Okay, number 9 is where I want to spend some time. Given a standard deck of cards, there's two problems here, and we're going to do them separately. Given a standard deck of cards, what is the probability of drawing a king, not replacing it, and then drawing a queen? There is a completely separate problem here that we will do completely separately. It's basically two problems in one. So I'm going to draw a line down the middle. And let's see what's being asked. Given a standard deck of cards, what is the probability of drawing a king, not replacing it, and then drawing a queen? This is important that we're not replacing it. So let's just see. Let's just set it up. If you're not sure where to start, just set up the equation. The probability of drawing a king and a queen, no matter what, if it's independent or dependent, I still set up my equation the same. I multiply the probability that I get a king by the probability that I get a queen. Okay, so let's see. The probability that I get a king. This is my first event, so my probability for my first event is always everything's up for grabs. The probability that I get a king, well, all 52 cards are available to me still. And of those 52 cards, 4 of them are kings. Remember, if you're not sure how many kings are in a deck of cards, you need to use your resource sheet. It's the same resource sheet that has the dice on it. Okay, and then I'm going to multiply that by, well, let's stop and think. What is the probability of drawing a king, not replacing it? I do not put it back in the pile, and then drawing a queen. If I pick a card and I put it in my back pocket, that means I only have 51 now to choose from. There is a king in my back pocket. That means if I fan out the cards, there's only 51 cards to choose from because I did not replace it. And then of those 51 cards, how many of them were queens? Well, my back pocket has a king inside and not a queen. So there still are 4 queens available. And then I will have 4/52 divided by 4/51, or 4/52 divided by or multiplied. Oh my goodness, sorry. And that will give me my answer. Whether I put it in my calculator or I know it off the top of my head, you'll probably want to use your calculator. You should get 4/663. Remember, it's okay to get those big numbers. Now, this next question's a little bit different, and it's a completely different problem, though, so we're going to start fresh. Now, what is the probability of drawing a king, not replacing it, and then drawing another king? And again, if you're not sure where to start, just start with your equation. The probability of getting a king and a king is equal to the probability of getting your first king times your probability of getting your second king. Alrighty. Now, this is a new problem, so everything's back up for grabs. The probability that I pick a king when all 52 cards are available is 4/52. Remember, all my cards are available. And then I'm going to stop this video now. There's one last video you need to watch to make sure that you understand this problem. One last one. It'll be very short.